Alright, let us look at another question in the chapter of triangles. In figure 6.20, DE is parallel to OQ, which means this line is parallel to this line. And DF is parallel to OR, which means this line is parallel to this line. Show that EF is parallel to QR, which means we are supposed to prove this line and this line parallel to each other. So let us write down the given data. Given DE parallel OQ, DF parallel OR. To prove EF is parallel to QR. Proof. So first, our strategy is to consider this condition that they have given. So if you take this triangle into consideration, you notice that these two sides are parallel to each other, which means this ratio is equal to this ratio based on basic proportionality theorem. Now we consider the other side of the triangle, which means this one, and we know these two lines are parallel to each other. Again, basic proportionality theorem states this ratio is equal to this ratio. Now by using the common ratio, which is PD by DO, we can argue that these two ratios are also equal, and by using the converse BPT, we can say that these two lines are parallel as part of this large triangle PQR. So in triangle POQ, PE divided by EQ is equal to PD divided by DO. Let's call this equation number 1, and the reason we ascribe is basic proportionality theorem. Let's look at this in the figure. PE divided by EQ is equal to PD divided by DO as a consequence of these two lines being parallel in this triangle POQ. Now let's take the other triangle. In triangle POR, we write PF divided by FR is again equal to PD divided by DO. This is equation 2, and the reason is again BPT. Now in this triangle POR, what we are saying is, because DF and OR are given parallel, BPT allows us to write PF by FR is equal to PD by DO. So from equations 1 and 2, since the right hand sides are the same, we equate the left hand sides. PE divided by EQ is equal to PF divided by FR. Let's call this equation number 3, and as a consequence of equation number 3, we can say this implies EF is parallel to QR, and the reason is converse of basic proportionality theorem, hence proved.